Okay, so if you remember from our earlier stuff, we spoke about our domain and our range, and our relation is a set of ordered pairs. Well, now we're going to talk about specific relations, and they're called functions, okay? Now, a function itself is a specific relation where for each x value, there is a unique y value, all right? So in other words, no x value produces two different y values. And it really is visually the easiest way to determine is if you draw your graph and you draw a vertical line through your graph and it cuts the graph only once, it's a function. So if you think about the graphs that we've done in the past, like parabolas, okay, cubic, hyperbola, truncus, all of those graphs, if you draw a vertical line, it crosses only once, yeah? That makes them functions. Whereas if you think about the only one really that we've looked at the moment that's not a function would be our circle. So if I drew a vertical line through a circle, it crosses twice, all right? And that makes the graph not a function. So let's have a look. Example 7. Sketch the graph of each of the following relations, state the domain and range, and specify whether the function is a relation, whether the relation is a function or not. So a few things there we have to do. We have to state the domain and range and specify if it's a function or not, okay? So very quickly, x squared, nice easy one to sketch. So there's a graph of x squared. Clearly the domain of that is R, all the reals. The range of that, let's write it as R plus union 0. Or obviously we could go from 0 to infinity, you know what I mean, any of those. Is it a function? Well, if I draw a vertical line, everywhere along there, it crosses only once. So yes, a function, okay? What about my next one here? X squared plus y squared equals 4. We just spoke about that. So that's a circle with a radius of 2. So everything is 2. Okay, so again, clearly the domain from -2 to 2 inclusive, so square brackets. The range also from -2 to 2. Let's don't forget that the range is these values, okay, the y values. Is it a function? Well, if I draw a vertical line, it crosses twice, so not a function, all right? Now it's important because functions have certain properties that relations don't, and we'll come to that. So it's important to be able to determine if a relation is a function. In terms of just some notation and things like that, we normally use the letters F, G, and H to represent a function. All right. So the full definition of a function, the function F. Okay, so it's telling me what the function letter is going to be. That first letter there is the domain. Really important. This one here, it's called the codomain, and throughout all of our time, it has no real significance. All we know is the codomain tells us that the range will be a subset of that. So there's probably not an instance in our methods course where that codomain isn't going to be R, and our range will be a subset of that, all right? And then we come in with the f of x part, okay, because we use f here, we've got f of x is equal to the rule, all right? As we said, x is the domain. It's not necessarily the range, it's a set that contains the range, and it's called the codomain, all right? So let's have a look at it a bit more. There's a fully defined function there. Well, it doesn't actually tell us what we're meant to do. Let's have a quick check. No. All right, so let's sketch that graph. We'll assume it says sketch the graph. Okay, we probably need to fix that, Mr. Garrett. So let's sketch this particular function. So what does it say? Let's talk about what it says. We've got a function f. So it tells me that the domain is from 1 to 5, and the rule is f of x is equal to x plus 2. Now that's the equivalent of saying y is equal to x plus 2 and x is an element of 1 to 5. Okay, so that's probably our relation notation we're used to. This is now our function notation. So x plus 2 is y-intercept of 2 and a positive gradient, except we're only going to sketch it between 1 and 5. So let's get my rubber. And it's, oops, rubber. So let's rub out that section. Let's put our line back in. And so my graph looks like that. So there's 1. And there's the 0.5. So let's just tidy that up a bit there. So there's the section of the graph that we need to be sketching. Solid dots at both ends. And let's try and work out what would our range be. Well, that point there and that point there. So at x equal to 1, y is equal to 3. At x equal to 1, at x equal to 5, y is equal to 7. So I've got the points 1, 3 to 5, 7. So my domain is 1 to 5, and my range would be from 3 to 7. Okay. Now let's sort of make sense of this notation a bit further. See over here, I said when x is equal to 1, y is equal to 3. Okay. Now another way of writing that could have been just writing, let's work out the function when x is 1. Okay, which is what this notation down here says. All right, so f of 2 means I substitute 2 in for x. So that's the same as 3 times 2 minus 9, which is equal to negative 3. F of negative 1 is equal to 3 times negative 1 minus 9, which is minus 3 minus 9 minus 12. F of t minus 1 simply means wherever I see x, I put t minus 1. Expand that, 3t minus 3 minus 9, 3t minus 12. And then finally, f of t is putting t in for x, which is just 3t minus 9. Okay, so that's what that function notation is. All right, what's this saying? For what value of t is f of t equal to t? So f of t has to equal t. So what does that mean? Well, f of t we've just worked out. So f of t is equal to t. Well, that means that f of t, which is 3t minus 9, has to equal t. So now I can just rearrange and solve, subtract t from both sides. I get 2t is equal to 9. So t is equal to 9 on 2. Okay, so we're just solving our equations. The way in which we're asked to solve it is just a little bit different. For what values of x is the function f of x greater than or equal to x? Very similar, isn't it? F of x, 3x minus 9 has to be greater than or equal to x. Subtract the x, 2x minus 9 is greater than 0. So we get 2x is greater than or equal to 9. So x has to be greater than or equal to 9 on 2. All right. So as long as the value is bigger than 9 on 2 or equal to, it's greater than or equal to. All right. If we keep following this process along, let's a bit more about our functions. Have a look at these graphs here. the rules are all f of x, g of x, or h of x equals to x squared. The only thing that's different is the domain that we're restricted, or that we're sketching it over. Here, x is an element of R. Here, x is between -1 and 1, which is where my domain is. And here, we've got x is R plus union 0, which is from 0 to infinity. Yeah? So that's what we call the family of functions. They're three different functions. They've got the same rule, but they've got different domains. So we call them restrictions. So G and H are restrictions of F, right? And the only thing that is different for them is the domains. All right, last couple of examples. Sketch the graph of each of the following functions and state the range. So notice in each of these, the domains, okay, the domains tell us what we sketch it over. So let's have a look at here. Let's undo that. So we've got the graph of y equals x. So we've done similar to this, y equals x between -1 and 2. So there's -1, there's +2, and my graph of y equals x looks a bit like that. Now, square brackets means the points are included. So that's what the graph looks like. All right. There's the domain. Now the range is going to be, well, the highest value to the lowest value. So what are these values here? So f of 2 is equal to 2 if I substitute into x. F of -1 is equal to -1 if I substitute into x. So that point there is the point -1. That point there is the point 2. So my range is equal to from -1 to 2. All right. Let's move on. Same thing. X squared plus 2x. So if I factorize that, I get x plus 2. So it's a parabola with intercepts at 0 and -2. So my intercepts there. What's the domain I'm sketching over? -1 to 1. So -1 is here. 1 is there. So normally my graph would be, down to there and then up. So square brackets. So I'm going to go to there and I'm going to go down to there. Now I've got to be careful. I do know that -1 happens to be the turning point because it's halfway between 0 and -2. So let's just really make sure we don't have that section. So that's the section of the graph. So, the domain will be equal to the lowest number. What's the lowest number down here? If I put x equal to -1, I get -1 times -1 plus 2, which is equal to -1. And if I work out the function at 1, I get 1 times 1 plus 2, which is equal to 3. So my domain is from -1 to 1. My range is equal to -1 to 3. Yeah? Just don't forget that's the range of values. All right? Finally, x squared minus 2x plus 8. So what does that look like? Well, we're going to have to probably factorize it, probably maybe even complete the square. We spoke about that a bit earlier, didn't we? To find a range, we need the turning point. So a couple of ways we can approach. I'm going to complete the square because they're all nice even numbers. So x squared minus 2x, halve it and square it. So it's x minus 1 all squared plus 7. So I've got a turning point at 1, 7. So my turning points say there, y-intercept at 8. So the graph looks a bit like that. And we're sketching it over all of R. So my domain is equal to R the range. Let's work from that point up, which was at positive 7. That's the 0.17. So my range is going to be from 7 to infinity. All right. So there's a lot in that. All right. Get stuck into it.